All right, everything with 10.4 was all multiplication. 10.4 was all adding and subtracting. 10.5 is all multiplication. Now, for part of multiplication, part of it's a little bit easier. Because when you're multiplying radicals, the good thing with this one is, as long as the index is the same, you can multiply anything you want to multiply. Doesn't matter if it's the same or not. So as long as the index is the same. Then you're going to multiply the coefficients, which is, again, your outside numbers. And then you multiply the numbers on the inside, or your radicands. Okay, and then the third thing, which is kind of optional, you're going to simplify the radicand if it's possible. Okay, so in that sense, it's a little bit easier because you don't have to get like terms and start adding terms. No, you just take the numbers, you multiply the outside numbers together, you multiply the inside numbers together, and then you break it down. So in that sense, some parts of it's not going to be as bad. Now, there'll be some other things we'll build to, but for most of it, the multiplication is actually a little bit easier. Because if you have square root of 3 times square root of 2, well, 1 times 1 on the outside, which is 1. On the inside, you do square root of 3 times square root of 2. Square root of 6 won't simplify. So for that one, you're done. Now, obviously, they're not all going to be that easy, but you know, they start you off with one where they make it where it's not too bad. So say you do square root of 6 times square root of 10. Okay, now, if you get one like this, where if you do this one, if you do 3 times 2, they're both prime numbers, so this was kind of almost a trick question. This one, you've got square root of 6. You can obviously break this one down. You've got square root of 10. You can obviously break it down. So here's what I would say. Don't do square root of 6 times 10 and make it 60, because what are you going to do with the 60 then? Going to break it back down, right? So if you know it's 6 times 10, if you know it's 60, and you know that you can take that 60 and break it down, well, go ahead and start breaking down the 6, because that would be 2 times 3. The 10 would be 2 times 5. So go ahead and break them. It's almost like one of those things where you almost want to break them down first and then put it all together. Now you got a pair of 2's, so you can take out your pair of 2's that's here. And then you've got a 3 and a 5 left over on the inside. So those would be left over on the inside. So that would be 2 square root of 15. Now, you could take the 60 and start breaking it down, doing the same thing. But if you take 60 and break it down, most people are going to write it as 6 times 10. So if you're going to take the 60 and break it back down as these two numbers, just go ahead and start breaking those two numbers back down. Now, technically, you're supposed to get the 60 and break it down. But if you get a number that you know that you can simplify, well, just go ahead and leave these two numbers and just break them down as they are. Now, if you want to, here you could go back and rearrange the numbers and make it 2 times 2 times 3 times 5, so they're all in order first. So that way you can see you've got your square root of 2's that would be here. So then you could take the 2 out, and you've got the 3 and the 5 left on the inside. If you want to do it that way, just to get everything lined up, that might be a little bit easier option of doing that one. Now, some of the numbers, they may throw a couple of sneaky ones at you. That you may do square root of 5 times square root of 5. Well, if you do that, that's 5 times 5, right? You've already got a pair of 5's here, so that would just be plain old 5. So every now and again, they'll give you some that when you put it out there, you're like, well, hey, that's 5 times 5 is 25. That's a perfect square root. Yeah, so you can just give me 5 as the answer. Okay, so they'll give you a few just to make sure you've got some numbers here. One little small thing that they'll do. They may do something like this, where they give you the square root of 7 squared. If they give you the square root of a number squared, remember, the square and the square root cancel each other out. Yeah, so you can just get 7. And they may actually write it two different ways. They could do the square root of 7 squared, but either way you go with that one, if you've got a square and a square root, they're going to cancel each other out and you get just the number that's there. So that's one where, again, they do that, but there's kind of a little bit of a shortcut to kind of get you through that one. Okay, so they kind of, basically let's throw that as an introduction. Say, all right, here's just some basic things you can kind of work on and kind of multiply through. Here's one where they give you the square root multiplication. They call this one a basic problem. We've got square root of 3 times square root of 27. Okay, now if you put 3 times 27, it's going to be a bigger number, right? We know we're going to have to go back and break it down, so why not just go ahead and start breaking it down as it is? That you can think about it as 3 times 27. 27, you could break it down, make it 3 times 9. 9, you could break it down, make it 3 times 3. So if you go back and start highlighting all your prime numbers, well, there's 4 3s. Well, there's a pair of 3s. There's another pair of 3s. So that leaves you with 3 times 3, which would be 9. And that's one where that if you actually had done 3 times 27 and actually wrote that number out, if you'd done 3 times 27, that would have been the square root of 81. So sometimes they get a little bit sneaky with the numbers, that if you actually multiplied them together, you would get the square root of 81, and then you'd simplify and break it down. Okay, so let's say you're doing square root of 32 times 2. Now, on the basic ones, let's go back and do those basic steps that we had. That they're both square roots, so if you do 32 times 2, 64, right? Perfect square root number, so you can take the square root of 64 and make that out just to be 8. So if you're working on these and it tells you it's just a basic number, just go ahead and multiply them together and you should get a perfect square root number. And that's kind of what they're looking at with this thing. All right, let's give you one more here. Okay, 2 times 6, square root of 12. All right, now in that case, it's not a perfect square root number, but again, it should be a pretty easy one to break down, because if you've got square root of 12, that would be 4 times 3. Now again, you could do 2 times 6, but if you think about perfect square roots, it's 4 times 3, square root of 4 would be 2. So then you've got 2 square root of 3. Okay, so if you see the part on there where it's basic or the intro, it should be really easy numbers to break down. They shouldn't go too awfully crazy with these. Okay, so they give you the intro, they give you the basics, then they throw out some advanced ones. And with advanced, by being advanced, you're going to have to work a little harder to get the numbers on these. Square root of 27 times 4 square root of 12. Okay, now, do you really want to do 27 times 12 and tell me that that is 300 and something? It's kind of big, right? So this is one of those where if you know it's going to be some big number, instead of getting that big number, go ahead and start breaking these numbers down, because 27, you've got the 4 on the outside, so we're good there. You've got square root of 27 times 12. Well, before you multiply those numbers together and get 300 and whatever that number is going to be, just realize you can start breaking these things down. 27, well, that's 9 times 3. Perfect square root with that one, right? So you could do the square root of 9, make that a 3. So there's 3 square root of 3. With the 12, if we do that one kind of here in green, 12 would be 4 times 3. You can do the square root of 4. So you can take that 4 out. Square root of 4 would be a 2. Then you've also got a square root of 3 that's left on the inside. So we already had the 4 out front. We took square root of 9, made it 3. We took the square root of 4, made it 2. You've got another 3 times 3. So that's 4 times 2 times 3. That's what? 8 times 3 is 24. On the inside, you've got 3 times 3. Well, that one left you with another perfect square root, right? Because there's a pair of 3s. So you can take that 3 out. So it's 24 times 3, or 72. Okay, so they give you the advanced ones. You're still working through that with just breaking it down as much as you can. Next thing they jump to, it's an intro. And it's a product of a radical expressions with univariates. Again, the only thing that's different about this one is it's an intro, so the numbers are easier. The part that makes it a little bit tougher is that they give you the variables. Okay, so you've got square root of 3 times square root of 2x. Now, the same setups are the same setup for this one. You're going to multiply the outside numbers, the coefficients. You're going to multiply the inside numbers, which is the radicands. And because it's the intro, you don't have to worry about breaking anything or doing anything down. These should just be basic numbers. On the inside, you've got 3 times 2x. That is the square root of 6x, and for that one, that is your answer. Because it's an intro problem, it should go pretty quick. It should be pretty easy. We'll save the hard ones when you get to the advanced part of it. You've got square root of 5z times square root of 7. Well, 5 times 7 is 35. Seems like you could break it down, but if you think about it, it's just 5 times 7. Those are both prime numbers, so that really won't break down any farther. So that's 35z. Okay, well, one more. Let's do square root of 10x times square root of 7x. Okay, and again, this is one where, again, it's an intro problem, but you got to kind of stop and think about it. You've got 10 times 7 for 70. What happens when you do x times x? How many x's do you have? Got 2 of them, right? So you can take that pair of x's and move that x on the outside. So it's going to leave you with x times the square root of 7. And it's almost one of those problems where they kind of lull you to sleep with a couple easy problems. And that one, sometimes people will just put 70x because they, but you got to realize you are doing x times x. So when you do x times x, it's x times x or it's x squared. If you think about that part. Okay, so there's the intro part. Still pretty straightforward. You're still multiplying it together. They're going to give you a couple of variables to kind of throw you in there. Okay, and for this one, it's the same problem, but they just take the intro off. So now you're simplifying the product of radical expressions where it's univariate. So this is just your, I guess, your maybe intermediates on these. So it just says to simplify, and they just take off the intro part. So this would be a non-intro. I don't know if that would be beginner or advanced or intermediate or something like that. It just takes off the intro part of these. So now we're looking at the square root of 3x to the third times the square root of 6x. Okay, and probably if you want to do these just from the easiest standpoint of what you're doing, just to kind of get a baseline. If the numbers are small, go ahead and multiply the numbers. Go ahead and do 3 times 6 and make it 18. And with your variables, you've got x to the 3, you've got x to the first. So if you've got 3 x's and one more x, then that means really you've got x to the fourth. So when they start giving you a little bit more complex on these, this is where you actually want to just go ahead and multiply it out together first. Go ahead and do 3 times 6 to make it 18. You've got 3 x's and 1 x's, so altogether you've got 4. Now you can break it up into 2 parts. If you do the square root of 18, that's 9 times 2. Square root of 9 is 3. And on the x's, if you do x to the fourth divided by 2, well, the good thing is that's evenly, right? That's x squared. So you've got a 3 and an x squared on the outside, and then you've got a square root of 2 on the inside. Okay, and again, if it's not the intro ones, I would say just so you don't get in too big a hurry, multiply your numbers together, and then take your variables, and then just realize if you've got 3 x's in this one and 1 x in this one, when you've got the 3 and 1, you're just going to add those together and make it x to the fourth. And then from there, you can go back and break it down. So this is one of those parts where once you get past the intro problems, don't get in too big a hurry. Just kind of take your time. Take a few extra seconds to kind of get through it. So let's do square root of 20b times the square root of 5b to the fourth. Okay, so multiply the numbers. 20 times 5 is 100. Hey, it works out nice, right? Got a perfect square root. With the b's, you've got 1 here and 4 here. So that would be b5. All right, now we've got square root of 100, so we know that's 10. And if it's b5, that's b. It's 5 divided by 2. So again, if you start thinking about dividing that one, 2 will go into 5 2 times with 1 left over. So we've got 2 b's that are going to go on the outside and 1 b that's going to be left over on the inside. So we're going to have 2 b's on the outside and 1 b on the inside. Yeah. So again, best advice on these when you start. Now again, if it's just the numbers by themselves, you can kind of work with them. But if you've got the numbers and the variables, just to be on the safe side, multiply your numbers together, and then break it down. Take your variables and add your exponents together. Again, if there's not anything here that's an understood one, and then break down the number, break down the variables. All right, let's give you one more of those. Let's go square root of 15 c to the third and square root of 5c. All right, 15 times 5 is 75. C to the third, C to the first. You've got 3 and 1, so altogether that's C to the fourth. Okay, 75, not a perfect square root number, so we've got to break it down. And for that one, if it's 25 times 3. And for the c's, well, that's going to be 4 divided by 2. So square root of 25 is 5. Got the square root of 3. And for the c's, when you do 4 divided by 2, well, that's just 2, goes evenly, so that'll be 5c squared. Okay, they change gears just a tiny little bit. They're going to ask you to simplify. You've got the roots, ratios, everything else. The difference on this one is, this one it says it's a multivariate. Or multivariate, whichever way you want to say it. Which means instead of it just being one variable, now you got 2 variables, or maybe 3. Probably not going to get 4, but you're going to have more than one variable. Let's go with the square root of 6. Let's go t squared x times square root of 2 t to the third and x to the fourth. Okay, and with a multivariate, same thing as the ones before it. Don't get in too big a hurry. Take it one little piece at a time. You do have 6 times 2, which is 12. With the t's, you've got 2 here and 3 here, so that's t5. For the x's, you've got 1 here and 4 here. That's also x5. And once you've got it here, now you're back to like we were back in section 3, where you're going to take the square root of 12 and break it down. So that's square root of 4 times 3. You can take the square root of 4 and make it 2. And then with the t's, well, that's t to the 5 divided by 2. And then for the x's, that's also 5 divided by 2. So for the t's, you're going to divide 2 into 5. 2 will go into 5 2 times, with 1 left over. And the x's, because it's exact same exponents there, when you divide the 2 into 5, it's going to be 2 with 1 left over. Okay. And everything here on top, this is going to be on the outside. Everything that's left over, that's what's going to be on the inside. So we already had this 2 square root of 3. The 2 is already on the outside. The square root of 3 was on the inside. We need 2 t's on the outside. We also need 2 x's on the outside. On the inside, we need 1 t, and we also need 1 x. Okay, so again, just take it one little piece at a time. Get everything together, multiply your numbers, add your exponents together, break down the number, break down each of the variables, and then figure out what's on the inside and what's on the outside. All right, let's do another one of those. Let's go square root of 3, v7, w4, square root of 6, v, w5. No, I think that's next time. Okay, so on your numbers, 3 times 6 is 18. You've got 7 V's here, 1 V here, so that's V8, which is a nasty drink all by itself. It's like drinking ketchup. Actually, ketchup would be better than drinking a V8. Then you've got W to the 9. Nothing like having, because we get the juice, the V8 blend, where it's got the fruit juice mixed in with it, where it's a lot of fruit juice with a little bit of V8. It's pretty good, and then you let a kid have it who's never had V8 before. That's funny. Yeah, the look on their face like, what is this you just gave me? Okay, square root of 18. 9 times 2, right? You can take the square root of 9 and make that 3. So that's 3 square root of 2. With the V's, that is 8 divided by 2, which is just, that goes out evenly, it's V4. So everything goes on the outside, there's nothing left over, so that one's just a V4 all by itself. With the W, that's 9 divided by 2. 2 will go into 9 4 times with 1 left over. Okay, so when we put it all together, we've got a 3 that's on the outside. The V4 went evenly, 2 divided into 8, so it's all on the outside, so that's a V4. We're also going to have 4 W's on the outside. We've got the square root of 2. This went out evenly, so nothing left over. We did have 1 W left over, so we still need 1 W left over there. Okay, so if you don't let it overwhelm you, it's just going back to the last part of 10.3, where we had just the different parts of breaking it down, where it went to multivariate, which meant it was just more than one variable when we were going through those. Okay. And then they change gears once again, which, and again, this part's kind of going back to some other stuff that we had before. This is intro to simplifying product of higher roots. Okay. The only thing that changes on this one is you're still going to do the multiplying like we did before. The only difference is now, instead of everything being square roots, now we're looking at third roots, fourth roots, fifth roots, everything else that it could kind of be. So the very first thing you're going to do is you're still going to go ahead and multiply this thing out. It is the fifth root of, and go ahead and do 4 times 8, make it 32. And like we did before, you've got 32, you got to start breaking it down. If you take the 32 and break it down, it's 2 times 16, which is 4 times 4, which you get 2 times 2, which you get another 2 times 2. 2, 2, 2, 2, and 2. So if you break it all down in prime numbers, that is the fifth root of 1, 2, 3, 4, 5. That's 2 to the 5th, right? So what happens when you take the fifth root of 2 to the 5th? Cancel each other out, right? You got fifth root, fifth power, they cancel each other out. Just get a 2. Okay, and it's intro. So with these intro problems, as long as it's intro, it should be just a simple, basic answer when you get to the end of it. Okay, so for example 2, Let's go third root of 15 and third root of 9. And if you do 15 times 9, that is 135. Now, if you check third root of 135, it's not going to come out nice and perfect. It's going to leave you some stuff left over. So if you start to break it down, now again, if you get stuck on this one, if you've got the 15 and 9, go ahead and break it down as 15 times 9, because that's the two numbers you multiply to get it there. If you want to use 5, you could, but we'll go from there. 15, if you break it down, that's 3 times 5. 9, break it down, that's 3 times 3. So when you break that one down, we've got them all lined up here. That is 3 times 3 times 3 times 5. Okay, and because it's the third root, you need everything in groups of 3. So there's a group of 3s that's here. The 5 is stuck by itself, so it doesn't have any exit buddies to get it out, so it's going to stay the third root of 5. Okay, so all the way, and again, these are all intro problems. So when you take the numbers and break them down, you'll either get something that comes out nice and perfect where everything cancels out, or most of it's going to cancel out. You're going to have probably 1, maybe 2 numbers left over that you're going to have to kind of go back and put it back together. But it should be that when you get here, you break it down, that you should just have a lot of 2s and 3s and 5s. And you're just doing them in groups of 3s, or doing it in groups of 4s, or doing it in groups of 5s, whatever index they give to you. Okay, now that one's kind of a odd little thing about itself because they give you the intro, they don't do any basics, they don't do any intermediates, they don't do any advanced. They just kind of throw that one out there, and it doesn't really, it kind of fits with the stuff we're doing, but it's kind of its own little separate island here. This is where they get back to more of the multiplying part here. And this goes back to kind of the first part that we were doing, that when you're doing the distributive property, they're going to tell you to multiply using distributive property. And for this particular set of problems, this one's an intro. Now, and this is really getting back closer to the first couple of problems we were doing, where you're just going to multiply the numbers that's your coefficients, and then you're going to multiply your radicands. The only difference is now you have to do it twice because it's distributive property. Okay, now this one should be pretty straightforward. You're going to do square root of 5 times square root of 7. So if you do 5 times 7, that is 35. When you do the square root of 5 again, now it's square root of 5 times 4. This 4 is on the outside all by itself. So when you do 4 times the square root of 5, well, that's your answer. It's 4 square root of 5. And if you could break down to 35, you could, but these were 2 prime numbers. So if you try to break them down, they're not going to break down because it was 2 prime numbers. Okay, example 2, same kind of problem, but just a little bit different on the setup here. Square root of 7 times 12 plus square root of 3. And again, with distributive property, you're multiplying square root of 7 times both of these numbers. If you do square root of 7 times 12, that one's a square root, this one's a whole number, so that one is just 12 square root of 7. When you do square root of 7 times square root of 3, 7 times 3 is 21. you could take 21 and break it down, make it 3 times 7, but you don't get anything else out of it. So for that one, again, that's your answer. So with the intro problems, they're just getting used to, okay, when you're doing distributed property, you multiply outside numbers together, you multiply the inside the numbers together. Now you just got to do it twice, so you've got 2 separate numbers. Go ahead. Okay, so for this one, we'll go square root of 6 times 9 square root of 7 plus square root of 2. And at the end of this one, they tell you to simplify as much as possible. And if they're going to make it a habit of telling you that, that means they're pretty much telling you, you're going to have to take some of the answer and break it down. It's not going to be like the intro problems where your answer was your answer. This one, you're going to have to work on a little bit. Okay, we'll still do the same thing here. We'll do square root of 6 times square root of 7. And again, if you want to put a 1 in front of that one, it is 1 square root of 6 times 9 square root of 7. So if you do 1 times 9, that's 9. 6 times 7 is 42. Okay, and then we'll do the same thing again. This time you've got, on the outside, it's 1 times 1. So that's 1, which we don't need it. 6 times 2 is 12. Okay, now 42. And you have to take my word on this one. 42 is one of those numbers that it seems like you should be able to break it down. And you can. But when you take 2 times 21, 2 is prime. 21 is 3 times 7. You get 2 times 3 times 7. You don't have any pairs of anything. So 42 is one of those numbers that it seems like it should break down, but it doesn't. That's as far as that one will go. So that part's good. Now, 12, that one you can make it 4 times 3. And where you got 4 times 3, you can make that 2 square root of 3. So that would be the answer that you're looking for. And again, it seems like you could do something with the 42. You can't. There's nothing you can do with it. All right, for example 2, let's go 3 square root of 3 times 4 square root of 3 plus square root of 7. Again, anything without a number in front, if you want to go back and put a 1 in there just to kind of make it look a little better, you can. So doing it the first time with the red, you've got 1 times 4 for 4. If you do 3 times 3, that is 9. We know the square root of 9 is 3. So that's 4 times 3 for 12. All right, second number in blue. We've got 1 times 1 for 1, so we just got a 1 here. 3 times 7 is 21. And again, if you take 21 and break it down, it's 3 times 7. You don't have any pairs of anything, so that one, there's nothing you can do there. So 12 plus the square root of 21 would be your final answer. Okay. So there's your intro, there's your basic. Pretty similar, pretty straightforward. Two more objectives. We'll go for the advanced. Yeah, they just skip intermediate and then they just jump you straight to advanced, right? Now, here's the thing with this one. It says it's using distributed property. It's not distributed property. For the advanced, this one's going to be doing the full method. Because it's a double distributed property. Think about it that way. So they don't say it's the full method, but anytime you're doing advanced, you're doing the full method. Okay, so let's go 3 square root of 2 plus 1 times 3 square root of 10 plus 2. Okay, so multiplying by 3 square root of 2, we'll do that one in blue. Multiplying by the 1, well, that's going to be easy, but we'll do that in red. Okay, so going on the blue line here, 3 square root of 2. 3 times 3 is 9. 2 times 10 is 20. On the second one, you've got 3 times 2, which is 6. There's nothing to multiply the square root of 2 by, so it'll just stay square root of 2. Multiplying by 1, 1 times 3 is going to be the exact same number. 1 times 2 is going to be the exact same number. Okay, now, and you can guarantee with the advanced one, you're going to have to take some of these numbers and break it down. There's no ifs, ands, or buts about it. You're going to have to do that. All right, square root of 20. 20, you could do 2 times 10, but let's do 4 times 5. Because if you do 4 times 5, square root of 4 is a perfect square root, so that's 2. So that's 18 square root of 5. All right, 6 square root of 2. You cannot break the square root of 2 down, so it's just going to stay 6 square root of 2. Square root of 10, that's another one of those that, yeah, you can take 10 and break it down as 5 times 2, but you don't have any perfect square roots. There's no pairs. So that 3 square root of 10 is all you can do with it. And then the 2 is a whole number, and so there's nothing to do with that one. And that's as far as that one will go because, and this is where you got to flash back to the first thing we did in 10.3. This one is square root of 5. This one's square root of 2. This one's square root of 10. The only way you can add and subtract is that if these square roots happen to be the same number. If they're different, you can't do anything with them. So that would be your final answer. Let's go 9 square root of 3 minus square root of 5 and 4 square root of 3 minus 6 square root of 5. Okay, so we're going to do 9 times square root of 3 times both of the numbers back here. So for that one, we've got 9 times 4 for 36. You do have 3 times 3 for 9. 9 times 6 for 54. And then 3 times 5 for 15. Okay. And again, I would say on these, especially when you're doing the full method, don't worry about trying to do 2 steps at once. Just multiply your inside numbers on your outside numbers on the first term. Then do it on the second term. Wait before you start breaking anything down. You've got negative, again, basically you've got negative 1, so negative 1 times 4 for negative 4, 5 times 3 for 15. Negative 1 times negative 6, that's a positive 6. 5 times 5 for 25. Okay, once you've got your 4 terms, now go back and see what you can simplify, because there's something in there you're going to have to be able to break down. You've got 36 times square root of 9. Well, square root of 9 is 3. 36 times 3 is 108. All right, the next 2 square roots. These are already square root of 15, so you can add these 2 together. Negative 54 minus 4, that's a negative 58. Square root of 15. And again, if you take about the 15, try to break it down, you get 3 times 5. You don't get any pairs of anything, so that's as far as that one will go. The last one, square root of 25 is 5. So 6 times 5 is 30. Okay, so you've got 108 plus 30. So if you do 108 plus 30, because those are two whole numbers, that would be 138. And then you've got the minus the square root that's left here, 58 squared to 15. Okay, so for those full methods, it's kind of 50-50. You're going to get a few in there, like the first one where you do it, and there's really not a whole lot of work to it. You're just going to get 4 separate terms. This is one where you'll get one where you get a lot of simplifying you can do, that you can keep breaking it down and getting the things here. All right, and one last objective. And this one, and actually this is just a special case of the full method. Let me just show you one of these, because there's really only one you need to worry about. Give you one more example here, and we'll go for this one. This one, it's still the sub part of this one. This one is conjugates and squaring. We're not going to worry about the conjugates, because the conjugates part is going to be exactly like example 2. It's just when you finish it up, this middle term is going to go away, and you're going to be left with just a whole number. And that's not a big deal. So that one, it'll kind of work itself out. We're really going to do the squaring part, because they're going to give you one like something like this. They're going to give you square root of x minus square root of 2 squared. Okay, now here's the big thing on this one. When they give you this one, you have to remember that you're going to write this twice. So it's square root of x minus square root of 2 times square root of x minus square root of 2. Once you do that, it's just a regular full method problem. Now you're going to do x times x, x times 2. If you do x times x, you can write it out as x times x. X times 2 would be a 2x. Let's see, that's a negative. Okay. We do the next one here. You've got negative 2 times x, so there's another square root of 2x. Do negative times negative, that's a positive. 2 times 2 is 4. Okay, pair of x's, right? So you can take that one, just make that x. You've got a minus square root of 2x and a minus square root of 2x on those. That's where you're going to add or subtract the numbers in front. So if you've got negative 1 minus 1, that's a negative 2 square root of 2x. Because that's the ones that kind of sneak in on you sometimes, because you forget about that 1 that's in front. Square root of 4 is 2. Okay. So the squaring part, it's a full method problem. It's just one of those that if you don't stop and write it twice, what most people are going to do is they're going to square this number, they're going to square this number, and you're going to forget about that middle term that's in the middle of this thing. That's the only thing you have to be careful of there.